How much it is? It is around 2 into 10 raised to 5. This much high gain of op-amp you get when it is in open loop configuration. And when op-amp is in closed loop configuration, you know, the gain is restricted by, it is either minus RF by R1 or it is 1 plus RF upon R1, depending on whether it is an inverting configuration or non-inverting configuration. So when op-amp is used in the closed loop configuration, you get some finite gain. And when you use op-amp in an open loop configuration, you get a very, very large gain. Ideally, we say the gain is infinite for open loop configuration. Now, what happens because of this large gain? This is typically for op-amp 741 IC. Okay. Now, what happens? Open loop configuration. Okay. This is op-amp. It is having two terminals and I am not connecting any feedback. Output voltage. Now you can apply signal to any one of this. Let's say you are applying signal over here and you are grounding them. Right? What happens when you apply signal? The gain is high. What is the gain? Gain is equal to the ratio of, if I want voltage gain, it is ratio of output voltage upon input voltage. When this is very high, when the gain is very high, you know, output can be written as gain into input. When gain is high, you will get a very high output, even though input is very small. Always remember that op-amp can provide you maximum output voltage that is equal to the supply voltage provided to this op-amp. Okay. In fact, it provides you a little less. That is, it provides you saturation voltage. Maximum output equal to saturation voltage. We call it as either plus or minus Vsat, right? So it is around 0.9 of VCC. If you are applying 15 volt or 12 volt, so 90% of that you will get maximum, okay? Or ideally, you will get the maximum output voltage equal to supply voltage, but not more than that. So whatever input you get, suppose, I will give you an example. Suppose gain of op-amp is 100 and you are applying input voltage as 1 volt. So how much output you expect? Output is equal to gain times input. Okay, how much input is 1 volt and what is gain? 100. So how much output is expected? 100 volt. Now this is your op-amp and you are applied VCC is equal to 15 volt and V is equal to minus 15 volt. So how that signal will look? The signal which you are supposed to get up to 100 volts, you will find moment signal, you will get the maximum output equal to 15 volts. So signal will get amplified up to 15 volts and above that whatever part is there that will be clipped up to 100 volt. इथे जर 100 volt होणार असेल तर वरचा पूर्ण portion कट झालेला असेल. Moment signal reaches up to 15, op-amp is saturated and you get maximum output, right? Again it will drop. It will move in this direction. Up to minus 15 the signal will get amplified and rest of the part will not amplify. How much output you are supposed to get? 100. किती मिळायला पाहिजे? 100. पण हा सिग्नल 100 पर्यंत जाणार नाही. Only from 0 to 15 it will increase and then it will be clipped. So this portion you will not able to observe, but you will get your saturated output. Okay. Now when I say gain is 2 into 10 raised to 5 or when gain is such a large, even if you apply a very small input, suppose you have given 10 millivolt, okay, even your input voltage is 10 millivolt. Student, am I audible clearly?
Yes, ma'am.
Even if I want to apply 10 millivolt, so gain is very high. So even input voltage is very small, output will immediately reach to saturation because gain is high. आउटपुट हे गेन टाइम्स इनपुट मिळायला पाहिजे. ओके, गेन एवढा जास्त आहे की इनपुट तुमचं अगदी थोडंही वाढलं तरी आउटपुट सॅच्युरेशनला जातं, राईट. Therefore, because of this property, we cannot use open loop configuration as an amplifier. Amplifier means you want a proper signal amplified. You want a complete signal at the output, right? But what is happening in open loop configuration? Some part of the signal is splitting. So this is not the correct, or this is not a faithful amplification. So for a faithful amplification, you must receive a complete signal. So therefore, you cannot use op-amp in open loop configuration as an amplifier. Are you getting? We can't use op-amp in open loop configuration as an amplifier. Why? What is the reason? Because its gain is very high. Therefore, a small value of input voltage drives the op-amp directly to the saturation. इनपुटची स्मॉल व्हॅल्यू असेल तरी सुद्धा लगेचच op-amp आउटपुटला सॅच्युरेशन मध्ये जातो. and once it goes saturation, you will get a constant output voltage. So it will able to follow the signal only for very small value. Therefore, you will get a distorted signal, which is not a faithful amplification. Therefore, you cannot use op-amp as an amplifier. Then what is the other use? I will draw the characteristics of op-amp as open loop configuration. V in versus V out. So here on this axis, I am applying input voltage. So you apply small input voltage, how this output will look like? It will immediately move to saturation. I will draw two types of curve. First of all, your increasing input. Okay. So let's say when you increase input by a small value, output directly goes to saturation. It remains in saturation. So only this much part of input voltage is amplified up to plus Vsat, and then continuously, even though your input is increasing, input small value input ची आली की तो लगेच saturation मध्ये जातो. नंतर input किती वाढू देत, it will give you constant output voltage. Similarly, here also. One can observe that only small value of input voltages are getting amplified. Only this much portion. It is linear rise आहे इथपर्यंत. But after this, from this point to this, it is constant saturation. So signal will be amplified during these values, these small values. After that, it will be saturated. Similarly, here also. This is the characteristics, VI characteristics of open loop configuration. Okay. Ideally, one can draw, if I want to draw these ideal characteristics, so here only I will show the graph. This is V in and this is VO. Ideally at 0 only. I mean ideally when input is 0, immediately it reaches to saturation value. But practically it amplifies the small level of input voltage and then it becomes saturation. So you can observe for small value of input it is increasing linearly. Output voltage is increasing linearly. On this axis what we are showing? Output. So for small input, output is increased, but immediately it becomes saturated. So this is the characteristic of open loop configuration of op-amp. Understood this characteristic? This characteristic is drawn between input and output voltages of op-amp. When you increase input, For small value of input, output increases linearly, but as you increase input, output becomes saturated. Same happens in the negative direction also. Now, then for what purpose we can use op-amp in open loop configuration? So it is having different applications. Okay, very important, large number of application this configuration is having, and it is the first of it will see comparator. Comparator. Can you read the screen, student?
Yes, ma'am.
Okay. Suppose I lost audio. You please inform on WhatsApp group or let somebody inform me because my Bluetooth device may get off. Okay. Now let's draw a comparator. I'll tell you one simplest easy technique to remember how this comparator works. What is the meaning of the word comparator? Comparator. What do you think what this circuit will do? Comparison. Okay. So for comparison, minimum how much inputs are required or how much things are required? Minimum two are required. If only one is there, I cannot compare. Comparator means the circuit which is performing comparison between minimum two input signals. Maximum it may have. Okay. So let's see that I am connecting inverting terminal to the ground and I am connecting non-inverting terminal to plus 5 volt. Two signals I have applied here. One is 0 volt. Grounded means 0 volt. Another is plus 5 volt to the non-inverting terminal. And here I will take output. Okay. Now, how this op-amp will work? How this comparator will work in this case now? So, comparator will compare the two signals. Okay. In this case, one is 0 volt and another is 5 volt. Whichever is greater, it will provide, you know now, the property of open loop configuration of op-amp to give output voltage equal to saturation voltage. Okay. Because its gain is very high. So, now it is having two signals. What it will do? Whichever is higher, it will give you the saturation voltage followed by the sign of that terminal where that input is connected, higher input is connected. In this case, one is 0 connected at inverting, another is 5 volt connected at non-inverting. So, which is greater? 5 volt is greater. Okay. So, op-amp will give you plus Vsat. Why? Because this is connected to positive terminal. हे लक्षात ठेवा. जो सिग्नल हायर आहे तो ज्या टर्मिनलला कनेक्टेड आहे follow that sign with Vsat. Open loop configuration will give you either only Vsat. So either it will be plus Vsat or minus Vsat. So whichever is higher, it will give plus Vsat or minus Vsat followed by that. Okay. So it will give you plus Vsat output. Okay. For example, let's draw the output. Output, let's show here. So it will give you plus Vsat. If I say I am applying here, let's say 15 volt. So Vsat you can calculate 0.9 into 15. Okay, 90% of 15. So that much value you will get. Now I will change this. What I will get? Who is greater? 5. This is 0. This is 5 volt. Which is higher? Which is higher? 5 volt. Where it is connected? Negative terminal. So it will give output Vsat followed by this sign minus Vsat. So in this case now, your output will be here. Okay, minus Vsat. Understood? Clear? Now, I am changing this. I am connecting AC signal. Okay. Here I am connecting to the non-inverting terminal. I am connecting a AC signal such that its amplitude is, let's say, 1 volt peak. 1 volt peak means 2 volt peak to peak. Understand this thing? What is peak? Peak to peak. I have this signal. I have this waveform. I want to measure voltage. So I will say either, suppose this is 5 volt 0 and this is minus 5. So I can measure peak from 0 to higher peak. I will say 5 volt peak. 5 volt peak. 5 VP, volt peak. So you can understand that from 0 to positive peak it is 5 or from 0 to negative peak it is minus 5. So peak is 5 volt. Peak it is a fast volt. Or I will say from this peak to this peak, how much it is? Yeah, 0 to peak means peak voltage. 0 to peak means peak. Peak to peak, किती होईल? 10 volt. So I will say 10 volt peak to peak. Or I'll write like 10 volt VPP. Got it? What is peak and what is peak to peak? Peak is measured from 0 to the highest peak or lowest peak. So 5 volt peak indicates either 0 to 5 towards positive and 0 to minus 5 towards negative. Okay, now let's talk about op-amp. I have connected 1 volt peak, means I will draw here 1 volt minus 1 volt. This is my waveform. This I have connected to non-inverting terminal and inverting terminal is connected to the ground. Now what will be the output? Yes. Will it be constant or it will be changing? First question. Everybody, online students. Output, in the previous case, I have drawn the output like this. Either plus Vsat or minus Vsat. Now, will it be same like plus or minus Vsat or it will be changing? It will be same. So, it will be either plus Vsat or minus Vsat. Are you sure? Think again. I'll draw the signal. My previous signal was like this. My previous signal was, I have applied 5 volt DC voltage. 5 volt. Okay. This 5 volt was continuous, constant. Now my signal is, now this is my signal. My signal itself is changing continuously. Here it is 0, it starts from 0, reaches to 1 volt. Then it drops from 1 volt, reaches to 0. Then from 0 it reaches to minus 1. Okay. Then minus 1 it increases, reaches to 0. Now tell me, will it be fixed? Where is your Vin? I have drawn here to non-inverting terminal for simplicity. Okay. So positive. First of all, the signal has started increasing from 0 and moving towards positive. So it is having positive peak. Which input is greater? This one or this one? This one is greater. So from here to here, output will be plus Vsat. How मोठा है ना? So plus Vsat. Okay. Okay, this is plus Vsat. Now from here to here, it is dropping 1 to 0. Who is greater? 1 आहे, 0.9, 0.8 and so on up to 0. Still it is greater ना. हा तर ग्राउंड आहे, हा 0 आहे. म्हणजे अजूनही हाच मोठा आहे. ओके, मी प्रश्न विचारला म्हणून चेंज नाही करायचं. ओके, so again I will get plus V sat. What is happening here? It has dropped now in the negative direction. Now what is greater? Now this ground level is greater. So here my output will switch to minus V sat. So and during entire negative half cycle, it will become minus V sat. Now when positive peak comes, again the voltage at non-inverting terminal is greater. So output will switch to plus V sat and it will be plus V sat for the entire positive half. Are you getting how output is changing? So I will label two things. या सर्किट मध्ये इनपुट दिली होती साइन वेव्ह, आउटपुट काय मिळाले? स्क्वेअर वेव्ह. झाले की नाही? सो आय कॅन यूज दिस ॲज अ कन्व्हर्टर, साइन टू स्क्वेअर वेव्ह. येस, दिस इज ऑल्सो कॉल्ड ॲज अ झिरो क्रॉसिंग डिटेक्टर. Okay, this is also called a zero crossing detector. What is this zero crossing detector? Let me tell you. Look at the input waveform. How it is? Sinusoidal, right? How is the input waveform? Sinusoidal. Now you see all the instances where this waveform is crossing zero. जिथे जिथे इनपुट वेवफॉर्म झिरो क्रॉस करते आहे त्या प्रत्येक ठिकाणी आउटपुट स्विच होत आहे. होते की नाही? Output is switching. So here first zero is crossed, output is changed. Here second zero is crossed, output is switched. Here next zero is crossed, output is switched. So where you form the edges of this square wave, it indicates the output, input is crossing the zero. जिथे जिथे zero cross होतो तिथे तिथे ही waveform switch होते. Okay? See, from positive it is switching to negative. जिथे zero cross. Then it remains in negative. Moment here zero cross, it switches to positive. So this application is also called a zero crossing detector. Got it? Conversion पण करता येतं. Suppose somebody tell you convert a sine wave to square wave. Simple application. Op-amp as a comparator. एका ठिकाणी साइन वेव द्या, एकाला झिरो द्या. So it is converting sine to square wave, right? Second, it is also called as a zero crossing detector. Clear? Any doubt in this discussion? Are you getting? What's your name, beta? Can't hear. Vaibhavi Bhosle. Okay. Are you getting? Now I will change the position. So what will, how this will, I will connect here sine wave and I will ground this. This is your input. Okay, and now I will draw output. Now you will tell me, this is positive half. What will be the output? Everybody, this is positive half. Input I have connected to inverting. During positive half of input, what will be the output?
Negative.
Negative, correct. What's that? Plus reset कसं येणार? Input positive आहे म्हणजे input हा greater आहे. It is connected to inverting. So sign of output will be minus. So you will get minus reset. Now here input becomes negative. This is becoming negative. Okay. So what is greater now? This is greater. So output will become plus reset during negative half cycle. जे तुम्हाला आधी मिळालं होतं तीच इन्व्हर्टेड मिळणार कारण आता हा इन्व्हर्टिंग ओपॅम्प झाला ना. हे कॉन्फिगरेशन कुठलं आहे? इन्व्हर्टिंग. बिकॉज आय हॅव अप्लाइड इनपुट टू दी इन्व्हर्टिंग ओपॅम्प. देअरफॉर व्हॉट एव्हर यू गॉट हिअर दॅट विल बी रिव्हर्स. हे इनपुट आहे हे टोटली रिव्हर्स होणार. जिथे पॉझिटिव्ह हाफ देअर यू विल गेट अ नेगेटिव्ह. फॉर नेगेटिव्ह विल गेट अ पॉझिटिव्ह. likewise. So don't confuse. Even in our unit number 3, regulators, I explained you how comparator operates. So this is in detail now we are discussing comparator. Okay, now one more. Instead of ground, I'll draw first a simpler one. So inverting terminal I have grounded, not grounded. Let it be. Connecting input to the inverting terminal and non-inverting terminal is applied with 1 volt battery. Maximum value of this is 5 volt peak. Okay. Where I have applied input? Inverting terminal. What is its value? 5 volt peak. And non-inverting terminal, second input I have applied as a 1 volt DC. This is DC, battery means DC. Okay. Let's draw both the signals. Yeah, 5 volt. And which is your second input? DC. I will show here. This is input 1 and this dotted line input 2. How much it is? 1 volt. So I must show it little below. If this is 5 volts, so let my 1 volt be here. Okay. 1 volt DC. एक dotted ने दाखवला आणि एक thick line ने दाखवला. Now, let's draw output. Everybody pay attention. Input is changing from, first input is changing from 0 to 5 volt maximum and second input is constant. Okay. Now I will say this is 0. From 0, 0.1, 2, 3, 4 up to 1 volt. One input is changing from 0 to 5 volt, 5 to 0, 0 to minus 5 to 0 continuously because it's an alternating signal and 1 is constant. So from 0 to 1 volt, okay. Let's say the instance of it is 1 volt time. So let's say it begins from 0. I will compare now both signal at every instant. At instant 0 of this input waveform, who is greater? जेव्हा इनपुट सायनोसाइडल इनपुटचा 0 इन्स्टन्स आहे तेव्हा कोण ग्रेटर आहे? दिस वन और दिस वन? हा वन आहे, हा फिक्स आहे, हा चेंजिंग नाही, हा चेंजिंग आहे. दिस इज कॉन्स्टंट. So who is greater? What is greater? 0 इथे व्हॅल्यू किती आहे? 0. इथे किती आहे? 1 volt. Who is greater? This is greater. Where it is connected to positive. What I will get output? Plus Vsat. Okay. Again for 0.2, 0.3 up to 1 volt. जोपर्यंत हा सिग्नल 1 volt पर्यंत येत नाही तोपर्यंत कोण ग्रेटर आहे? हा ग्रेटर. Okay. Moment the input comes up to 1 volt, this input is greater, 1 volt, which is applied to non-inverting terminal is greater. So I will get, I will mark this moment. Okay, so from this point to आता इथपासनं बघा, from this to this DC signal was greater. Above, moment your input signal crosses 1 volt, 2 is greater now. AC signal is greater. Okay, so AC signal is greater till this point. Again, when it starts decreasing, still AC signal is greater. कुठपर्यंत? इथपर्यंत. So here you will get output equal to minus Vsat. Okay, you will get output equal to minus Vsat. Further, what will happen? पुढे बघा. So from 1 to 5 volt, AC signal is greater. It is connected to inverting terminal, so you will get inverted output, that is minus Vsat. Okay. So this will continue up to this crossing point. At this point, what is happening? Your input is dropping below 1 volt. AC signal is dropping below DC signal. Right? Now who is greater? DC signal is greater. So your output will switch to plus Vsat. Okay? It will become plus Vsat. Here, what is greater? DC is greater. Here, this is entire negative half cycle. So again, your DC signal is greater. Kutparanta till this point. Itparanta. So this plus Vsat. Here onward, AC signal is becoming higher. So you will get output minus Vsat. Again, you will get the next plus Vsat at this position. So every instant of time, both the inputs are compared. One which is greater, you will get output Vsat with the sign of that greater signal. Clear? Clear? Now you draw a circuit where this position shall be replaced. Draw a circuit where this position is replaced, changed. There are only 19 students. Is there any problem in joining? Is there any problem in joining? All students, reverse the position of inputs and draw the output.